Hey everybody, this is Mr. Beckstrom, and today I want to take a look at section 2.1. We'll talk about the different topics that are introduced in it, and we'll look at some examples. So we're going to be looking at average velocity, instantaneous velocity, and slope of the tangent line. Now it's really important that we read these sections and we read the definitions and we look at the examples because it will help enhance our understanding of the material. Now once you read the section, I don't expect you to understand everything right away. But I really like to take a three-pronged approach in this class, and that means, you start by reading the section. You might pick up a few things here and there. Some things might seem familiar from something you've done before, or you might get a couple of the concepts. And then you watch the video, and hopefully that'll make some of the topics a little bit more understandable. And then finally, you're going to be working on the problems. And that's really where the kind of the full understanding comes into play. So it's really important that we read the sections, watch the videos, and that we also try these problems. And I'll give you a couple of problems in the video to try as well as the homework problems in my math lab. All right. So let's talk a little bit about average velocity here. So average velocity is pretty much just what it sounds like. So if we have some function here, and let's call this function f of t, if we take 2 points on this, any 2 points, we're going to have both a t value, the independent variable, for both points, and we're also going to have an f of t value, kind of like a y value, for both of those points as well. So really, when we talk about the average velocity, we're just talking about the slope between these 2 points here, right? And that should give us the average velocity. And how do we find slope? Well, in this case, we're going to be looking at, let's say this point here is t1, and this point here is, and this point here is t2, just like we would find the slope in pre-calculus. We're going to use the difference of our vertical values over the difference of our horizontal values. So it'll look something like this. F of T2 minus F of T1 all over T2 minus T1. Right, just like we would if it was like a slope. Remember, the slope is y2 minus y1 over x2 minus x1, and we have the same kind of idea here, because if we talk about the straight line between those 2 points there, let's see if I can get kind of a straight line, then the slope of that straight line here is going to end up giving us our average velocity. Now, what is the instantaneous velocity? Well, we can kind of use this here in order to get that as well. So I'm going to use a blue line for that. And the instantaneous velocity is the velocity at, or the slope of the tangent line at any one point. And that would be our instantaneous velocity. So in this case, let's say we wanted to find the instantaneous velocity, our instantaneous rate of change at t equals 1. We would go and find the tangent line. Remember, if you've never worked with the tangent line before, the tangent line is the line that comes through and just touches this curve, the black curve here, at one local point there. So if we look at a real close neighborhood around that point, this line comes through, it barely touches it, and then it keeps going without actually crossing through. And the slope of this line here, that would be our instantaneous velocity. And then really that's going to end up being the slope of our tangent line. And the blue line here would be our tangent line. So one graph here kind of explains all three of these. And this also leads into physics, which we'll be talking a little bit about in the form of velocity and acceleration. So if we have a point or a position point that's kind of moving back and forth, we can take the derivative to find the instantaneous velocity, and then the second derivative to find the instantaneous acceleration of that moving particle. And that is something that we're going to be looking at soon, not in this section, but I just kind of want to get you an idea of what these are used for. And these are also going to lead us into the idea of the limit, which brings us to integrals and derivatives, which is the main bulk of this course. So the course will be about a third limits, about a third derivatives, and then finally about a third integrals here. All right, so let's go ahead and work this problem here. Now notice that they didn't give us an equation here for this. What they did is they gave us a table, but we're still going to do the same kind of idea here. They use S instead of F, but it says the table gives the position S of t of an object moving along a line at a time t over a 2-second interval. Find the average velocity over the following intervals. So once again, we don't have a function to use, but we just have a table, but we can still do that. So remember, in this case, it will be S of t2 minus S of t1 all over t2 minus t1. All right, so at this point here, go ahead and pause the video and see if you can find out the the average velocities for these 4 points, and then we'll come back and we'll do C and D. All right. Okay, let's see how you did here. So let's take a look at C first. So C says 0 and 1.5. So the first point will be our T1, the second point will be our T2. And then if we look at S of T1, we just go to the 0, and S of T1 is 0. And then for the 1.5, we go to 1.5. So S of T2 will be the 66. So this is going to be S of T2 for the, this is for, oh, I'm looking at B here, aren't I? So 1 here, so 0 and 1. So 0 is here, S of T1 is there, and then T2 is here, and then the one below it would be S of T2. All right, so for C, we're going to have S of T2, which is 52, minus S of T1, which is 0, all over T2 minus T1, so all over 1 minus 0, and that's just going to give us 52 over 1, which is 52. And that should be our average velocity for the points 0 to 1. Okay, if you didn't get that first one, go ahead and pause now and try D. All right, for D, we're going to basically do the same thing, except this time we're using the points 0 and 0.5. So S of T2 is going to be 30, minus S of T1, which will be 0, all over T2, 0.5, minus T1, which is 0. So this is going to be 30 over 0.5, which should give us 60. All right, let's move on to instantaneous velocity here. Okay, for the next problem, it says given the position function f of x is equal to negative 16x squared plus 64x, complete the following. First, they want us to find the slopes of the secant lines. Remember, the secant lines are the lines that go through 2 points that pass through the points x, f of x. So this is going to be x. Here's f of x right here, and 2 f of 2. So here's 2, and there is f of 2 up there. And then they give us different x values for 0.5, for 1.9, for 1.99, for 1.999, and then finally for 1.9999. And then secondly, we're going to make a conjecture about the value of the limit of the slopes of the secant lines that pass through these points as x approaches 2. And then finally, we're going to say, what is the relationship between your answer, part B, and the slope of the line tangent to the curve at x equals 2. So we got a lot going on here. So let's try to take a look at this graph and see what we're doing here. All right. So if you want to go ahead and try this, go ahead and pause the video now, and then we'll break it down a little bit, and we'll go over sections A, B, and C here. So go ahead and pause now. All right. What we're really trying to get to is we're trying to get to the slope of the tangent line that goes through the point here to f of 2. And that's going to look something like this. Let me change that to a color I am not using. All right. And, oh, they actually already give it to us here, right? So that red line there is the slope that we're looking for. And if we see that slope, remember, slope is rise over run. This looks like a horizontal line, so I'm guessing that the slope of that tangent line is going to be 0, but we're going to find out here. But what we need to do is we need to first check for the secant line of these 2 points here, or the slope of the secant line that goes through these 2 points here, and then we'll need to check some values that are closer to 2, so we're going to be moving this way towards 2 in our x values, which are going to be moving this way in our kind of our y values here. And then we're going to see what we get, or make a conjecture about what the slope's going to be when we get to the very top here, where this value 2f of 2 is. All right, and for this, I'm going to go ahead and use my calculator. So it's really important that we have the TI-83 or TI-84 calculator. That's the format that I'm going to use. And if you want to be successful in the class, make sure you use that. And once again, these videos are recorded, so you can kind of go back through and see what I did. So go ahead and pull your calculator out now, and then unpause when you have it. So you should have a key format that looks very similar to this. If you have the TI-83 or TI-84, this is a TI-84 right here. And what I'm going to do is I'm going to go ahead and put in a function here of this one right here. Hold on just a moment. All right, so you're going to hit the y equals key here in order to enter the equation, and we're going to stick this equation in here. It'll make it a lot easier for us to calculate some of these values. So I'm going to go ahead and do this. Remember, don't use a minus sign if it's a negative. You have a negative sign down here. So negative 16x, here's the x key, squared, plus 64x. And that's going to be saved under my y1. All right, so now for x equals 0.5, remember what we're going to do. We're going to be doing f of, excuse me, we're going to be doing f of 2 minus f of x, right, to find the difference in our y values. And that's going to be over 2 minus x. And then we're going to have these x values here. So it's going to look like this. F of 2. Let me change that back to black. So f of 2 minus f of x all over the x values here. So that's going to be 2 minus x. All right, so what we need to figure out for this one is what is f of 2? And for the first x value, we're going to do f of 0.5. So this is going to be, this is part A here. So we are going to grab the calculator back, and I'm going to do f of 2. So what I can do with this is if I go to vars, and then y variables, and then go to function here, and this says pull up my y1 function and put in a 2. And let's see what that is, because I'm going to be using these in a lot of my calculations here. We're going to get 64. So f of 2 here is equal to 64. And that's always going to stay the same for all of these. And then for the f of x, that's going to be 0.5. That's the first value we're using. So I'm going to do the same thing, except I'm going to go in and put in a 0.5. And that gives me a 28. And then over 2 minus 0.5. So for this very first one, we're going to have, this is going to be equal to 64 minus 28 all over, got a better minus here, all over 2 minus 0.5. And let's see what we get here. So pull the calculator back up, and I'm going to get 64 minus 28. That gives me 36, and we're going to divide that by, and I'll put this in parentheses here, 2 minus 0.5. All right, and 24. So the first one here is a slope of 24. So the from 0.5, wherever x equals 0.5, it doesn't tell us where it is here, so it's probably right about here. The slope of that secant line going through that point, and the x equals 0.5, is a slope of 24. So I want you to go ahead and try the 1.9, and then we will check that. And then after you try that, I'm going to show you a little trick to use the table in the calculator and make this a whole lot easier. All right, go ahead and pause the video and try x equals 1.9 now. All right, so now what I'm going to do is I am going to set up this equation with, since f of 2 stays the same, I'm going to just put in 64. It's just our x value that's going to be changing here and here. So how do we set that up? Well, let's go ahead and do that now. All right, so what I'm doing now is I kept the same equation under y1 here, and then for y2, I'm basically putting in this formula here. Remember, f of 2 is always equal to 64. So this is my top up here. Now, it's really important that we put parentheses around the entire numerator and the entire denominator, so we do the correct order of operations. Now, I'm going to be subtracting. I'm going to be using different values here, so I need to put a variable in here. And this says minus. We're going to go to my y1 equation and evaluate that at whatever x I put in there for it. And this is going to be over 2 minus x, over 2 minus x. So all I have to do at this point is go to second window, make sure that this is my table set up here, make sure my independent variable is on ask and my dependent variable is on auto. This means that I'm going to put in my t's, and or my x's in this case, and then it will spit out, it will automatically spit out my f of x's, which is going to be my y1 and my y2. And remember, my y2 should actually give me this equation here of the slope of that secant line for all of these x values here. All right, so let's go to table. I've already put in 0.5. And it says when we evaluate 0.5 in equation y1, which is just the equation that they originally gave us here, we get the 28. That's where we got this 28 here. And then y2 is the entire thing, and that gives us 24. So now I'm just going to go ahead and use this to find my other ones. So for 1.9, I just put in 1.9, enter. And you can see that my slope of that secant line is going to be a 1.6. So now let's try 1.99. It's gone down to 0.16. Let's try 1.999. It's down to 0.016 and 1.9999. And you can see that this value here is getting smaller and smaller and smaller. It looks like it's approaching 0. So, what does that mean? That means that I can make a pretty accurate conjecture that if I look at the slopes of the secant lines, as this x value gets closer and closer to 2 from the left-hand side, that my slope of that secant line is getting closer and closer to 0, which makes sense because when I actually get there, it looks like the slope of that tangent line, the line that just goes through the single point there, is equal to 0. So what is the relationship between your answer to part B and the slope of the line tangent to the curve at x equals 2? Well, they're both the same, right? Because our conjecture said that this was getting closer and closer to 0, and that looks exactly like the slope of the tangent line at the point x equals 2. All right, so let's go ahead and move on to the last part. All right, for this last problem, we're going to try to see what the slope of the tangent line of this function here at x equals 1. And we're going to make a table of slopes of secant lines, and then we're going to make a conjecture. That means that we're going to take a guess. So yeah, there's a couple of things I can do here. The first thing I want to do is just go to my calculator, and I want to put this function in here, and I want to take a look at it and see what it looks like at x equals 1. That's going to tell me whether the slope is positive, whether it's negative, whether it's close to 0, whether it's close to infinity. It'll kind of give me a good idea of what I'm looking for. That way, if I get something that's totally different, it's a good way for me to check on my errors. So I'm going to come back up here, and y equals, we're going to go ahead and change this formula up here to this one right here. So we're going to do x cubed minus x. And we can delete the rest of this stuff here. Oops. Never mind. Let me try that again here. X cubed minus x. All right. So the first thing I want to do is, and I'll update this one in just a moment here. You can turn a graph off by just going over the equal sign and hit enter. So if it's not highlighted here like the y1 is, then it's not going to show up on your graph. And then I just want to do a standard graph that's going to go from x equals negative 10 to positive 10, and the same for y's. And this is what it looks like. So if I were to, let's go ahead and zoom and do a little text box, or a little zoom box, right around x equals 1 here to see if we can get a better idea. Hit enter, and notice, let's move this cursor here until the x value gets right to 1, or very close to it. And then I want to kind of, there we go, that's your x pretty close to 1 here. So it's at this point right about there. So we're looking at a positive slope. This slope does not look that steep, and it doesn't look that low level either. So I'm expecting some kind of slope, maybe around 1, up 1 over 1, up 1 over 1 at this point here, because we're just kind of doing a nice diagonal line here. So that's what I'm expecting when I do this. Now let's go back to the y equals, and we're going to let the calculator do the work for us again. So we have this function. Now we need to change this first value. Why? Because this was for the last one that we did. So at f of 1, if we put a 1 in this first function, that's going to be 1 cubed, which is 1 minus 1, which is 0. So I should have a 0 right here, just leaving me a 0, and delete there. So it's going to be 0 minus the function evaluated at the x that we put in, all over, and our new x value is 1, so I'm going to go ahead and change that to 1. So this table here should go ahead and allow us to pick numbers that are very close to 1 and see what that slope is approaching. Now remember, I'm already guessing that I haven't actually done this yet, but I'm already guessing that slope is somewhere around 1 because it was a positive, just kind of a generic, like I said, not too steep slope. So let's go ahead and do this. So we're going to make sure that we go to table set first, that this is on ask and that's on auto. I always check that because sometimes when you reset your calculator, restart it, it goes on auto, and it won't let you put anything in the table. And then I'm going to go to my table here. Let's delete all that out. And we're going to start picking numbers. Let's start from the left-hand side of 1. So that's less than 1. So if I do like a 0.9, I get 1.71. If I do a 0.99, I get, now this is actually closer to 2 than 1, but it's still positive. So here's my slopes here, because I put the slope formula in the y2 equation. And let's do 0.9999, like 4 of them. And we can see that this value is getting closer and closer to 2. Let's check from the other side. Let's check from the right side. So I'm going to start with 1.1. Notice I'm over 2 now, but I'm going to get closer to 1. I'm going to go 1.01. And notice I'm getting even closer to 2. And how about 1.001? Let's do one more 0 there just to be absolutely certain here. And as you can see, my my slope there is getting closer and closer to 2. So for this one here, I can say with a pretty moderate degree of confidence that the slope of the tangent line at this point here is equal to 2. Now let's go ahead and actually graph that tangent line here and see. This is just, it's not asking for us to do this, but I like to do that. So let's go ahead and see, first of all, we have a point at x equals 1, y equals 0, because if you put the 1 in there, you get a 0. So we have a point at 1, 0, and our slope that we calculated for that tangent line is equal to 2. So let's just put this in our point slope formula. So that's going to be y minus y1, and that's my y value for the point here, is equal to m, that's our slope, times x minus x1, which in this case is 1. So solving for y, we're going to get 2x minus 2. And now I'm going to go ahead and go to my calculator. And let's go back to y equals, and we're going to go down to y3. And I'm going to, let's go ahead and turn this one off again so we don't see that. We just want to see our basic function, and then we want to look at that line there, 2x minus 2. 2x minus 2. Enter, go back to the graph, and look at that perfect fit here. So that line with the 2 slope looks like it's definitely that tangent line. It comes right to that point there, touches it without ever actually crossing through that curve at a local neighborhood there. All right, guys. Hopefully this helped. Make sure that you work the exercises in my math lab. If you want to work some extra exercises, there's plenty at the end of 2.1. And please use the forums if you have any questions. And we'll see you next time. Thanks.